Hey guys, fifth time recording this year. Today I'm doing LeetCode 19, remove inf node from end of a list. Given the head of a linked list, remove the inf node from the end and return it head. So with an n of 2, the first node from the end is 5, the second node from the end is 4. So we remove 4. You can see in the example output 4 has been removed. So to solve this, I've written out a new linked list and a new n. So we have an n of 3 and a linked list of size 6 here. And as you can see, the node we want to delete is node 4, and it's indicated here with a star because the first node from the end is 6, the second node from the end is 5, and the third node from the end is 4. Third node from the end is 4, and is equal to 3. That's the node we want to delete. Put a star next to it. All right, cool. So now we know that. What we want to do to calculate what is our target node, we can see with our eyes that the target node is 4, but how can we get the computer to know that? First, we'd have to know the length of the entire linked list and just subtract n from it. But how do we know the length of the linked list? We're going to have a variable called count. So let's say count is going to equal 0. And what we're going to do is have a variable called cur, and it's going to traverse the linked list until we get to reach null. And every time we reach a new node, we increment by 1. So 1, and then we'll get here 2, 3, 4, 5, 6. So as you can see, this linked list has a size of 6. If it doesn't make sense now, when we get to the code, everything will make much more sense. You'll see exactly how I'm doing it. But here, we're just going over the high-level explanation. Next, since we know the count, now we can initialize our target. So target is just equal to count minus the n. So count is 3, count is 6, n is 3, so target will be 3. As you can see, the first node from the back is 6, second node from the back is 5, and third node from the end is 4. So that's the node we want to delete, our target. Yeah, it's a target node. Now, what we want to do is we're going to actually, since we know the length, and cur is up here because we traversed the list, we want to initialize cur or reassign cur back to head. So cur is going to start at the beginning. And we're going to make count go back down to 0. And we're going to traverse the list for a second time. But instead of going to the end, what we're going to do is say, wow, count is less than n. And I'm going to show you exactly how that works. But this time when we traverse, we're going to have a pre-variable with cur. And they're both going to be equal to the same thing, the head. But prev is going to stay one step behind cur. So in this example, I'm just going to move up cur for now to show you how this works. And we're going to, so every time we move up cur, we're going to move count up 1. So count is now 1. Here, count will be 2. And then 2 would go up to 3. And then let's see, would it go again? Is 3 less than 3? No, it's equal to, so we'd stop here. So as you can see, count would go all the way up to 3. And cur would get to the 4th node. And we're just going to have pre-shadow all of cur's moves one step behind. So prev would be here. And after we get here, all we want to do is say prev.next equals cur.next. And .next is just the pointer. So .next equals cur.next. And what is cur.next? It's 5. So prev.next would go like this. And then when we read the list from the beginning, it would go 1, 2, 3, 5, 6, essentially deleting this node 4. And that's all we have to do. All right, this would work in 99% of examples, but let me show you an example where it actually wouldn't work, a bit of an edge case. So let's say instead of n being 3, n was 6. So we go through the same thing again, and target would be 0 because the length is 6. 6 minus 6 would be 0. And our second condition would say, when we traverse the second time, while count is less than target. Count will never be less than target because they're both 0. So it would actually skip this and just say that prev.next is going to equal cur.next, right? They're both the same thing, so it wouldn't change the list. So if n was 6, it wouldn't delete this one node. It would just return the head of the linked list normally. To prevent that, what we're going to do is have a single condition and just say, if target equals 0, return head.next. And let's say, so if target 0, that means we want to delete this node here. Just return, and this is the head. So head.next, which is the 2. So everything from 2 onward, we want to return, and that would essentially delete that one. Hopefully that makes sense to explain the edge case, but I'll show you guys here. All right, so let's get into the code. First, we want to initialize count. So let count equal 0. Let cur equal head. And we're going to say while cur equals cur dot next. So we're just moving until we reach null. And we want count to go up each iteration. So now we know the length of the linked list, and that's count. So now we could say let target equal count, which is, in this example, would be 6, minus n. So that would be 3. So our target is 3. Now we're going to get ready to traverse the list a second time. But as you remember, cur is all the way at the end. We need to put it back to the head of the linked list because we want to traverse the second time. So cur equals head, and count is still at 6. We want it to be back at 0 so we can count again. So count equals 0. Next, we're going to initialize prev. So let prev equal head. And here we go. We have everything. So in this current position, we are at here, and current and previous are both at the head node. Now we're going to say while count is less than target, we want to have prev equal cur and cur to equal cur dot next. And just to illustrate that a little bit further, let's say cur moved up one time, cur would be at 2, cur equals cur dot next. But before that, we said that prev equals cur, so cur would actually, prev would stay exactly where it's at, and cur would move up, essentially having that gap that we wanted. Next, cur equal prev equals cur, so prev would be here, and cur equal cur dot next would be 3. So essentially, there'll be a 1-step gap in between each iteration. Cur equals cur dot next. Next, we want to say prev dot next equals cur dot next, and return head. And as you remember, this would work, but remember our edge case when target is 0. So we want to check it up here. So if target is equal to 0, we want to return head dot next. And this should work. Let's try it out. Cur equals cur dot next. What has happened here? I found the bug. Count was not being incremented, so we want to say count plus plus, because so it would actually just run forever. And this should work. And there you go. That's how you solve LeetCode 21. There's a bit of hiccups, but we did get it solved. Let me know if you have any suggestions, any concerns, comments, anything like that. Like the video. Peace.